Hi everyone, Mr. Rato here. There's some questions posed by Alfonso, so I'm quickly going to go through this. Hope you're all well and safe. Okay, so clearly he's managed 1, 2, and 3, but let's just quickly check here. I like to do the whole question before I move on to these parts. So it goes here, estimate how many students took the examination. So you look at the top of this cumulative frequency and you look at that. What is the maximum that reaches? Is well, that's 580 and it's the 590. So that's 590 is the highest peak there. So that's cumulative frequency. How many students took it? So I'll say 590 pupils. Number 2, how can you tell that no student scored more than 55 marks? Now, if you look at 50 marks there, you'll notice the cumulative frequency levels off. Okay, so the cumulative frequency curve does not increase, in which case maximum score there, the highest mark, therefore max mark is 55. And then it goes here, find the greatest possible range of marks. Now the greatest possible range of marks is, obviously we said that 55 is the maximum mark, and looking on here, the cumulative frequency just picks up from there. Okay, so you could actually say it's just after 14 it picks up, so you could say 15 or 14 marks, it doesn't really matter. You get a range of marks acceptable. So if I said that it just picks up, that's the first candidate there, 15 marks. So if we say that the greatest possible range, we say 55, take away 15, and that'll give us a range of 40 marks. Okay, if you want to put a maximum mark, you could even go down to 14 here, get 41, so that's okay. Right, let's look at this. It goes here, the minimum mark for a grade C is 27 marks. So if we go to 27 marks and draw a straight line going from 27 marks, okay, just seeing if I can do any straight lines with this. That'll be okay. So if I go along here, about here. Okay, that's 180. I'm going to put that 180. 180 people scored less than 27 marks. Now it goes here, the number of students who gained exactly grade 7, grade C, was the same as the number of students who gained lower than grade C, so 180. Let's make the maximum mark. So basically, if there's 180 students here that scored less than 27 marks, and that is the same amount of students that gained grade C, so 180 plus 180 is 360, because they're exactly the same. So cumulative frequency, when it's 360, 20, 40, 60. So if we went along here, since that is 360 and that's 180, so all these students between here achieved a grade C, which was 180 students, which is the same as the ones that scored less than a grade C. So the maximum mark here, I'll bring that down slowly in a straight line, use a ruler please, it's going to be 31 marks. So for here, we can say 31 marks is an estimate for the maximum marks for grade C. Okay, so from 27 to 31 marks. Okay, let's look at this next one. In German examination, the marks of the same students have an interquartile range of 16. Okay, what does this result indicate about the performance for the students in German examination as compared to the French? Okay, so we're looking at the interquartile range. Right, what am I going to do here? What I could do is, yeah, if I use a different color, I'm going to use blue. So let's first of all get the interquartile range here. So we said there's 590. So 590 divided by 4. Okay, so calculators. And just quickly do that. 590 shared by 4. So my lower quartile now is 147.5. So I'm going to call that this. Right, I'm going to call that about 148. So my lower quartile, I'll put here for French, lower quartile is where is 148 into frequencies. Let's look at 148. So that's 100 and 20, 40 and 8 is in the middle. So if we went about there, okay, again, 20, 40, 8 is about there. So we're looking at about 26, 27, round about those marks. Okay, so let's say it's about 20, it's a bit more than 26. So let's just say 26 marks is okay. So 26 marks there for the lower quarter. 26 marks, if we look at 26 marks, that's 100, actually 10, 20, yeah, that's okay. And then if we look at, if I times this by 3, okay, it's times 3, we get 142.5, sorry, 442.5, which I can round up to about 443. So for the upper quartile, it's going to be equivalent to frequency 443. So if we look at where does 443 lie, so here, let me just quickly put this down. 40 was about roughly there. I'm going to go roughly down to there. 26. This is called the lower quartile. We look at the upper quartile, which is 143 marks. That's 44, but there. It's only a rough estimation, so don't worry too much. So it's going to be slightly there. If I bring that all the way down, that's going to be 35 marks. So my upper quartile marks is going to be 35 marks. That's my upper quartile. Now, if I get the interquartile range here, so I'm going to go, if I go to the next slide, say, so my interquartile range is going to be 35 marks minus, subtract the 26 marks, which gives me 9 marks. Now remember that, just from the question, if we go back, remember the question for the interquartile range for the German marks was 16. Okay, so this is for interquartile range for French students and interquartile range for Germany. German students, so people doing the, let's call that German students, apologies, and that was 16 interquartile range. Now 16 is greater than 9, therefore the or they're the same students. So this German subject had a greater interquartile range, which implies these these marks were more inconsistent and had a larger spread. Okay. In essence, French marks were more consistent. The French marks were more consistent. Okay, any of those will do to get the 3 marks. Key thing is you show your marks. Working out to show the interquartile range, you're going to get your 2 marks here to show that your interquartile range for French marks was 9, and then compare that with the 16 where you did here, and you get the 1 mark for here. Okay, the next question Lanza asked me was question 5. Now, I think you just asked me for part 2, but let's have a look at this, or let's build it through. So it goes here for each of the 4 cards has a number printed as shown below. 2 of the cards are chosen at random without replacement. The random variable x denotes the sum of the numbers of these 2 cards. So show that the sum is 6 and show that the sum is 4. That's its problem. So let's just start with the first one, I. Now, probability that the sum is going to be 6 is you can pick select. So that will be the chances of probability of picking 3 followed by 3 again. So the probability of picking a 3 and a 3, so I'm just going to denote this, picking a 3 and a 3. Okay, makes it easier. So probability of picking 3 and a 3 is, the first 3 is going to be 2 out of 4. And then you've picked one of the 3, so there's only 1 3 left out of, so one of these cards are gone, there's 3 cards now left. So it's 2 times 1 is 2, 4 times 3 is 12, which gives me 1 6. And that's what this extra is, so that's done. Now it goes, show that the sum is going to equal to 4. Now that will be the probability of selecting. Now the way to make 4, you could pick a 1 and then a 3, or you could pick a 3 and then a 1. Now picking a 3, as picking a 1 and a 3 will be, picking a 1 will be 1 out of 4, and means 2 times. Getting a 3, there are 2 3s out of 3 cards left. Or means add, and this is probability of picking a 3. Now picking a 3 first will be 2 out of 4 times in, then picking a 1, there's 1 out of 3 cards left. Now this one will be 1 times 2 is 2, 4 times 3 is 12, plus 2 times 1 is 2, 4 times 3 is 12, 2 out of 12, 2 out of 12 is 4 out of 12, which is 1/3, and that is the same as required. Okay, now it goes here, write down all the possible values of x and find the probability distribution of x. Now when we're doing this, now first of all, x, which is the sum, now, and this is the probability of x being x. Okay, so what can the sum be? The sum can be, you can pick a 1 and then a 2. So that's the minimum you can get, which is 3. You can't pick 1 and a 1 because obviously once you picked it, it's not replaced, so you can't pick that again. Okay, just be careful. So you could get, the minimum is 1 and a 2, or you could pick 1 and a 3, which is 4. We've already worked out the probability. You could then pick a 2 and a 3, which is 5. And you could pick a 3 and a 3, which is 6. Now we already worked out the probability of 4. The probability of sum being 4 is 1/3. And the probability of 6 is 1/6. Now you could work out these two afterwards. Probability of getting 3, x being 3, is probability of getting a 1 and then a 2, or picking a 2 then a 1. So picking a 1 is 1 out of 4, followed by there's 1, 2 out of 3, and this will give you the same probability. Picking a 2 is 1 out of 4 times by 1 out of 3, so you've got to double this. So that's going to be 1 out of 12, and then we double this because you got 2 ways of doing it. Okay, you could pick the 1 and the 2, or the 2 and the 1. So double that will give me 2 12s, which is the same as 1/6. So that's 1/6. Okay, so yeah, that's 1/6 of it. Now, probability of selecting the sum of 5, making the sum of 5, you could get probability of picking a 2, then a 3, or you could pick a 3 first, and then a 2. Okay, so what is that? Picking a 2 first is 1 out of 4 times by 3, there's 2 out of 3 left. And picking, that's now the next one, picking a 3 is 2 out of 4 cards, and then once you pick the 3, picking a 2 is 1 card out of 3. So note these two are also the same, so 1 times 2 is 2, and 4 times 3 is 12, and since you got that same calculation, you just double that, and that's going to give me 4 out of 12, just same as 1/3. Now if you collect this, that's 1/3, that's 1/3, 1/6 plus 1/6 is also 2/6, which is 1/3 also, 1/3 add 1/3 add 1/3, and this will give you a sum of probability of 1. Okay, now you haven't asked me for E of x and variance. It's really straightforward. Expectancy is just this multiplied by that, add 4 times 1/3 plus 5 times 1/3, and plus 6 times 1/6, and the variance will be, you square this, the 3, sorry I didn't mean to do that, the variance is just, you square this, times it by that, square this, times it by that, and take off your E of x squared from that. Okay, just wondering if I've got space. What I could do here is quickly go through that to show you how to do it. Okay. Right, I'll just quickly show you how to do variance and expectancy quickly. So let's get this table drawn at the bottom. So you've got x and the probability, make it small x, and as we said before, this was a 3, a 4, a 5, and a 6. Just quickly look at this. That was 1, 6. Okay, so that's 1, 6. That's 1/3. That's 1/3. And that's 1, 6. So E of x is just 3 times 1 out of 6 plus 4 times 1 out of 3 plus 5 times 1 out of 3 plus 6 times 1, 6. And you can just quickly run this through your calculator. I'm just going to quickly say that's going to be the same as a half. And that's the same as 4 over 3. And that's the same as 5 over 3. That's the same as 1. So that's the same as 9. 9 out of 3. 9 over 3 is just 3. So that's going to be 3 plus 1 is 4. So that's going to be 4 and a half. 4, 8, 9 halves. Okay, so the variance is equal to E of x squared minus E of x all squared. Okay, so that means 3 squared is 9 times the probability is 1 over 6 plus 4 squared is 16 times 1/3. So I'm squaring all these numbers here and then multiplying by the probability. Then 5 squared is 25 times 1/3, and 6 squared is 36 times 1/6. And you can easily do this on your calculator, which I'm going to do now, and then take away E of x, which was 4.5, 9 over 2 squared. So just quickly grab your calculator there, and you get 9 over 6, add 8, add 25 over 3, add 6. Okay, and that's going to give me 143 over 6, take away 81 over 4, so minus 81 over 4, the answer will equal to 43 over 12, or if you want to write it as a decimal, that would be 3.58. Decimal place of 3 single figures. Okay, so if you want to call it 4.5, so that's the E of x, and that's the variance. Okay, now let's go to the last question that was asked by Lorenzo. Okay, sorry, Alfonso. There are 10 numbers in a list. The first 9 numbers have a mean of 6 and a variance of 2. The 10th number is 3. The mean and variance of all 10 numbers. So find the mean. Okay, so first of all, mean. Let's just write this down. The mean of 9 numbers is 6. So n is 9 numbers, and the variance of those 9 numbers is 2. Okay. So first of all, if I want the mean for the 10 numbers, that will be Well, the mean was 6 for 9 numbers, so 6 times 9 plus the 3, which is the 10th number, and I divide that by 10. So 6 times 9 and 54 plus 3 shared by 10, that is 57. Shared by 10 is 5.7. Okay, that one's done. Now, the variance. First of all, we know that the variance for the 9 numbers, well, the formula for the variance is the sum of x squared over how many there are. In this case, well, let's write the formula divided by n minus the mean squared. Now, in this case, I know that this is 1 to 9. So the sum from 1 to 9 x squared divided by, so there's 9 numbers there, minus, and I know that the mean for the 9 numbers was 6, so that's going to be 6 squared. That's going to equal, and the variance is 2. So we have this formula that we need to solve now. So 6 squared is 36, so I'll get the sum of x squared 1 to 9 divided by 9 minus 6 squared is 36 equals 2. Take that to the other side. Opposite of minus 36 is plus 36. Okay, and then I'm going to times that by 9. So the sum from 1 to 9 of x squared is going to give me, well, 2 times 36 is 38 multiplied by 9, because that was being divided by 9. So let's just quickly do that in the calculator. That's going to be 38 multiplied by 9. That's going to give me 342. Okay, so now we've got exactly what we need now. So if I want the variance of the 10 numbers, I need all the sum of x's squared. So I know that the sum of all the x's from 1 to 9 of x squared plus that 10 number, which is 3 squared in this case. So now I've got all the x squareds divided by 10 numbers. Take away the mean squared of the 10 numbers. Now we worked out the mean of the 10 numbers, which is 5.7, and I'm going to square that to take it off. So this will give me the sum of all the 9 numbers is 342 plus this 3 squared is going to be 9, so that's going to be 342 plus 3 squared is 9 all over 10 minus 5.7 squared. So we'll get plus 9, we'll get 351 divided by 10 minus 5.7 squared is going to be minus 32.49, and this is going to be divided by 10 is 35 points. Take away 35.1 from there, we'll get a variance of 2.61. Okay, so that's going to be the variance for the 10 numbers, and this is the mean for all the 10 numbers. Right, okay, Alfonso, hope that helps. See you later, take care, bye.